So good afternoon. Yes, my name is Guno Son, Associate Professors in the Geomatics Engineer Program in Lasong School of Engineering at York University. So I'm very happy to welcome you here today and joining our webinar series. And we're delighted to have you participate and share in our 10th GeoTalks virtual seminar series. And this presentation is going to be the last the webinar series for the 2020 and 2021. So thank you for joining this meeting today, and many of you remotely attended from different places, I know, and thank you. And Geomatics Engineering Program at York University was founded 20 years ago, and this year's we're going to celebrate the 20th birthday of our Geomatics Engineering programs at York University. And for the last 20 years, many students from our programs has been graduated and who now be working in various fields as a leader and as engineers and scientists, entrepreneurs and educator. So our program also have primarily contributed to geomatics research community and industries, and by conducting innovative research projects. So I'm going to very shortly, and I'm talking about the GeoTalks. And GeoTalks is a bi-weekly seminar series organized by Geomatics Engineering Program in York, and together with the Canadian Institute of Geomatics Toronto branch. And this series will host industry leaders, entrepreneurs in geomatics. And this is an opportunity to hear from industry leaders in geomatics and who will introduce their cutting-edge geospatial technology through this seminar series. So today, we are honored to have Mr. Theodore Hanchevici from Kongsberg Geospatial. And Theodore is a senior architect, software developer, and who has experience over 15 years designing and building complex systems and solutions. He has served as a technical architect and technical lead and a software engineer on a range of geospatial related solutions and a development project for a diverse set of clients. He has a great deal of experience as a skilled problem solving, capable of balancing user requirements and technology advancements. His software development skill has been focused on producing high throughput software for GIS and geospatial application using object-oriented methodology and C++, Pythons, and variety of programming, with the different environments. As a senior technical lead and software engineer on a marine multi-domain control station, MMDCS project, and the Theodore oversees a multi-partner team with a focus on addressing technical issues associated with software development, system integration, and engineering tasks. It supports the development of troubleshooting, testing program, analyzing, evaluating solution to ensure the project will meet intended requirements. In addition to his technical responsibility, and Theodore is Kongsberg Geospatial's standard committee representative. And in this role, he works with various unmanned vehicle and geospatial related standards committee participating in the review, enhancement, and development of industry related technical standards. In his talk today, and with the title of Towards a Generic Command and Control System for Unmanned Vehicles, and Theodore will share his visions and experience with us. Now, Theodore, the floor is yours, and I'm going to stop sharing my screen and you can share your presentation.
Thank you everyone for joining us to the presentation about the generic command and control system for unmanned vehicles. I'm Theodore Hanchevici. I'm with Kongsberg Geospatial. And today I'm going to talk briefly about Kongsberg, about two of our products that deal with unmanned vehicles, Iris and Medusa. If you can go to the next slide, please. and then describe the command and control system that we are working on. Next slide, please. Kongsberg Geospatial is part of Kongsberg Group, which is a Norwegian company based in Kongsberg. We have 11,000 employees, about $2.7 billion in revenue. We have offices in 40 countries, and it's publicly state-owned. We are owning Rolls-Royce Marine and Patria. Next slide, please. Kongsberg is divided into 3 divisions: Kongsberg Defense and Aerospace, Kongsberg Maritime, and Kongsberg Digital. And Kongsberg Geospatial is part of Kongsberg Defense and Aerospace. Next slide, please. We develop software for real-time geospatial applications, and our tools are used primarily in defense systems and to display live sensor data on control systems. We are found in air traffic controllers, submarines, and Navy ships. Our TerraLens product family provides a comprehensive real-time mapping and sensor data display with 2D and 3D visualization, real-time air tracks and ground tracks display, line of sight, and spatial analysis. Next slide, please. We also do beyond visual line of sight missions, and we are specialized in visualizing airspace in real time for beyond visual line of sight flight control. And our IRIS system provides flight capabilities for applications like pipeline and power line infrastructure inspection, as well as deliveries and others. We do provide in the fleet operations a single comprehensive real-time picture of the terrain, airspaces, and all the aircrafts in the area. And the fleet operations are used mainly by drone delivery companies. Next slide, please. So as we said, IRIS UXS provides mainly airspace awareness, aeronautical information, as in obstacle airspaces. It integrates AIS, ADS-B data, as well as radar feeds, and provides you a common operating picture display. It's optimized for semi-autonomous UAS, and it's deployed within multiple drone delivery companies. Next slide, please. So this is just to give an idea of how the airspaces are displayed, and you can control the drones, you can see where they are, as well as other drones in the neighborhood, as well as if you have information, you can see the airspaces, you can get alerts if you are going into an airspace that's restricted, or you can define your own airspace and you can be notified if somebody comes in within your airspace. Next slide, please. Medusa is a multi-domain control command system. It allows you to operate multiple systems in multiple domains. What do I mean by that? It allows you to operate in air, surface, and underwater, as well as ground. So you can integrate and create missions across these domains and monitor all the assets that you have in the area. We are in partnership with Martin UAV, which provides vertical and takeoff and landing vehicles, and they are deployed on Canadian Navy for unmanned aerial reconnaissance, and Medusa is a command and control for them. Next slide, please. So as you can see here, it's a more complex example where you see the airspaces as in orange and purple. You can see the planes. You can see hostile and friendly entities, as well as your own vehicle. Next slide, please. So what we notice is that there is an increase into commercial space. And if we look at various statistics, we'll say a projection is by 2025 to go to $12 billion a year in the market, and 2 million drones sold yearly worldwide, which will make for quite a busy space. If you go to the next slide, we see that there's a lot of interest, mainly in healthcare and arts, public administration. However, we see that mining and constructions and agriculture keep growing in the enterprise drone applications worldwide. And if we go to the next slide, the underwater vehicle market exhibits the same pattern of growth, looking toward a $2 billion market value by 2028, which means that the waters will get busier in some areas, and there's a need to have a situational awareness, at least for the operators. And the next slide is the same pattern that you see in the unmanned surface vehicles, where by 2025 the growth is to be close to $3 billion a year. And the trends are a lot of increasing research in the hydrogeography, a need to monitor anti-submarine warfare, as well as monitoring for artifacts from previous wars, mainly mines that were left that pose serious threats to traffic, both military and commercial. Next slide, please. So we see this increase of need to plan and execute missions across domains, and we see a need to monitor and get a situational awareness across multiple domains. It's mainly in maritime exploration and monitoring in coastal areas. We do have asset inspections and monitoring that will require multiple domain vehicles to collaborate. And unfortunately, operators will have to go through various ground control system trainings for the same domain, and not to mention if they need to operate multiple vehicles across multiple domains. Next slide, please. So a couple of use cases that we've encountered discussing these problems are the basic ones being the situational awareness, second one being a beyond visual line of sight control involving multiple ground control stations, supporting new vehicles using an operational deployed ground control station, failure and maintenance of a computer or a GCS system, the need of mission approval or flight approval or vehicle deployment approval, as well as vehicle replacement. So I'll go through each of the use case and describe it a little bit. Next slide, please. So the situational awareness, it's what we see today, where we have multiple entities operating in the same area. We have multiple companies flying drones in the cities, but they're not aware of where the other vehicles are. They're only aware of their own. There is effort to enforce an ADS-B transmitter on drones. However, not all of them have, and the regulation is still developing. So we have the risks of collisions, difficulties in planning and executing missions, and at least having a standardized telemetry information being shared across the entities will help alleviate this problem. Next slide, please. In the beyond visual line of sight control, we can have multiple vehicle operators that have different ground control stations, and they will monitor and control a vehicle beyond visible line of sight. So what you can imagine is that you have a long range vehicle with a couple of hour endurance and you want to monitor a pipeline or to do a long delivery across the country, and then you transfer the control from a ground control station to another ground control station, and they may not be the same ones. And then the standardized telemetry being shared by all participants, services publishing telemetry for vehicles will help you in monitor as well as control potentially the vehicle. So command and control standardizations is helping in this case. Next slide. It is also very possible that you get a new vehicle within your organization or a set of new vehicles, and they will come with their own ground control stations. So bringing them up to speed will have a cost because you have integration delays, you have multiple parties involved if you want to get support in your ground control station, or you have to train your crew to deal with the new vehicle and how to interact. That is something relatively small versus you still want in your common operating picture, for instance, if you're a mining company where you have the trucks, the autonomous trucks moving, and you want to also see the new unmanned vehicles flying, bringing a new one will be a potential lengthy process. And therefore, a C2 standardization helps simplifying this process because your vehicle will speak the same language as your GCS or your common operating picture software. Next slide, please. Another scenario is a ground control station failure. So you are in a scenario where you are executing a mission, you are doing inspection or you're doing a survey, and one of the computers is failing. Having a standardized command and control will allow the other vehicles at least to take over and do an emergency landing or an emergency stop, or you can monitor and control vehicles irrespective of the manufacturer. So again, we're looking at standardization of certain aspects of command and control to facilitate the end users. Next slide, please. The mission approval and submission is something that both FAA and Eurocontrol is discussing, and there are agencies in other countries that already offer a way for you to submit a flight plan for your drone for approval. However, the operators and authorities cannot easily collaborate, and you can simplify the process by having the mission information standardized and being pushed towards the authority in a standard format. Next slide. Vehicle replacement, again, it's a scenario where you are loading and you are ready to execute a mission, but you want to swap the vehicle with one from a different manufacturer just for simple reason that the vehicle doesn't operate to the desired parameters. You don't want to incur delays. And if you have similar capabilities, then you will be able to swap them and push the loaded mission into the vehicle and complete the task that you execute. So again, the mission information, mission planning, and command and control standardization helps achieving the goal. So what is the current situation? Current situation is a bit of a Tower of Babel. We have lots of standards for air. We have 4586, which is a NATO standard. There's Mavlink. There's FACE from Open Group, which is US Army. There are standards for surface and subsurface like JAWS from SAE, Janus from CMRE. However, there's no standardized way, at least to get telemetry, is to get a situational awareness. And there is an upcoming 4817 STANAG standard, but this is a NATO standard, and it's aimed towards defense. It's not aimed towards a commercial entity. And we saw the increase of commercial drones projected by 2025, thus having a standardized way to interact with them or to obtain the information from them will help the commercial users. Next slide, please. So the difficulties that we see right now are mainly to plan and execute a multiple domain mission, because most mission planners are single domains. Vendors are selling you a vehicle or selling you a mission planner and all the great tools with them. However, those tools are meant for a particular domain. They don't understand underwater vehicles, or they don't understand air vehicles. The OEM tools that they usually tie to the vehicles, it's quite few offer an SDK that allow you to actually bring that information into your system. So the integration is very difficult, and that is one of the lessons that we learned in doing some of the projects. And a standard approach is nice to have, because it allows the information to flow better. Next. Next slide, please. So we started a project called SUIT, which is a standard-based unmanned vehicles interoperability testbed, which is a collaboration with Seabite Limited in Scotland and 4D Robotics in Ottawa. It is a single control station using data distribution service, like a DDS data model. It is multi-domain, multi-standard, and multi-vehicles. So we can integrate with STANAG 4586 and Mavlink, as well as JAWS. And we do that for air, surface, and underwater. We do vehicle payload discovery and control, as well as mission control. Next slide, please. So in terms of discovery, you will bring the vehicle online. It will automatically appear in your control station with the capabilities, the status, what payload it has, and what capabilities it has. As far as mission vehicle control goes, you can switch between a manual mode and the mission mode. Most of the vehicles are autonomous, so you load the mission and you tell them to go and execute. However, you can pause that mission and tell it to loiter, to stop, go to a waypoint, wait, have various commands. Next slide. As far as mission control, we can load missions, query missions that are loaded, start, pause, resume, and abort the mission, which means in the case of inspection, you can say, I want to inspect this power line or this pipeline. Basically, this is the set of waypoints, and you take pictures here and here, and you here and there, and you just send the vehicle away. However, you can tell the vehicle to stop, or you can tell it to abort and to return back home. Next slide. In terms of payload, we can get payload information, change payload settings, control streaming, capture images, control gimbals, by setting it to a lock mode to look always at the ground position, or do a direct control and do recording control and start, meaning as you start or stop recording on payloads that support that. Next slide. So as an overview, SUIT is basically a UI on top of a data model where and the DDS data model is the part that's standard, and that it gets translated to one of the protocols like a JAWS, a Mavlink, or if it's an OEM specific, we can translate that using an OEM SDK to that particular protocol, and we send the messages, we translate them, send them to the vehicle, and we control it. Next slide, please. So the 4586 integration is an example of how this is achieved. So we have again the DDS data model, which is the standard part, the standard commands, and they will get translated to a set of standard 4586 messages that go to a base station, and then they interact with the vehicle-specific module that goes to a proprietary protocol to the vehicle, to the autopilot, and the autopilot executes the commands. Next slide. So due to the standardization, the same DDS messages will now be translated to JAWS, and they will go through the same route into a JAWS to VSM, where a JAWS message gets translated into a vehicle-specific module, or if the vehicle supports directly, JAWS goes directly to the vehicle, and commands are executed. Next slide, please. So when I'm talking about a data model, it's basically a set of DDS topics and structures, basically a definition of what information I want. Like I want the position will be longitude, the latitude, and a series of altitudes. Can be above ground, above mean sea level, depending on the vehicle. But it is a unified way to describe behavior and receive the information, and that is the part that makes it powerful. That you send the same information out, and you expect to multiple vehicles or multiple protocols are hidden from you as an operator or as a system integrator. And it is a challenge response model in the sense that we always expect an acknowledgement for the command that we send. Next slide, please. So here is an example where it's a very, very simple example where we have a pause mission command, and that we will send out on the DDS bus, and we expect a mission command status message in return from the vehicle. So we send this. The intent of a pause mission command is to stop the vehicle and put it in a safe pattern. So in case of an air vehicle, will loiter or will hover in place depending on what it is, and will not continue the mission that is currently, or the action that is currently performing. And in return, we expect a mission command status message, which basically tell us what is, in which state are you. Ideally we expect like a paused or a failure, and why it failed. Next slide. So this is how the standardization translates that. As a DDS topic, you are always concerned about the action of pausing the mission. And in the 4586, you will send a series of messages that are specific to that protocol. And you will get back message 106 telling you that everything is fine, the vehicle is loiter, and you can report back that the mission status is paused now. And next slide, please. In JAWS, you send the same message out. You still want to pause a mission. However, you you translate that into a series of JAWS messages, where you can say, well, you get a post-mission message and you get back a report mission status message. So as far as the standardization goes, everything that's on the DDS, or everything that's between the console and the other bridge or the vehicle is standardized. And as long as somebody implements a bridge to DDS, then you get a new vehicle very, very easily. There is another, keep in mind that we have two standards here. We have the JAWS, which is an SAE standard, and the so-called DDS series of topics that are standard within this product. You can bring a vehicle that speaks JAWS and behaves the same way as the sequences of messages that are specified in the diagram, and that vehicle will also do a pause mission. Next slide, please. So what goals we try to achieve with Suite? Well, we want to provide a standardized data model. We can look at OGC observation and measurements and enrich them. We want to provide a standardized command and control model, which allows us to easily integrate other vehicles. And we want to provide a standardized payload control. So it should be transparent which manufacturer is, it shouldn't matter which manufacturer has produced the gimbal. You want to control the gimbal in the same way. You want to trigger an image capture in the same way. And next slide, please. And so we want to provide a standardized mission planning format so that we can link into the FAA and your control work, and you can submit your plan no matter what vehicle you have. You will the mission plan will be the same, and it will be sent for approval. However, we don't want we're not looking here to create a web service or a web infrastructure, because some of the commands and some of the messages will have a different latency. And in some cases, we have asymmetrical connections to vehicles. So meaning that the bandwidth is different for uplink and downlink. Next. We do not want to dictate a middleware either. We just want to standardize the definition of the messages as IDL or XSD and say, this is the data and this is the intent. And if you are DDS based or AMQP or any other middleware based, you will still be compliant to the standard as long as you submit the same messages and you submit the same information. So that doesn't prevent or doesn't force anyone to adopt a particular middleware, but if they use currently a middleware, they can still be compliant and they still can interoperate with other systems. Next slide. So what's Kongsberg doing on this front? So we're actively engaging with OGC. We will set up a few experiments and integration tests. We are looking for participants and we're looking for feedback from either from vendors, from commercial operators, and from any other entities. We're always looking for ideas, and we're looking for people and partners who can help us or who feel that this is of interest to them, and we love to hear their feedback. And this is the last slide. And so thank you very much for your time. And if you have questions, I'm more than happy to answer them.
thank you so much. It's a very interesting presentation, right? So first, I think I'm going to collect some questions from the audience, and please, to give the write your questions to me so that I can deliver your questions on behalf of you. Okay, everyone. Okay, so now, okay. So Taylor, the overall the ideas is, I think the what I'm trying to understand is before we get into the more detail, and perhaps the ship transportation community is also have sort of their own ways for how to exchange their locations and navigation information each other. And likewise, the connected vehicle communities and other communities already starting to do so, right? If you have any knowledges about it, and could you share us what other domains people's efforts versus what unmanned vehicle community does? For example, AIS is sort of the antenna system, so they, any ships actually have to transmit the signal and to the guard in the oceans, and so that they're asking them to notify them where they are when they're navigating in the oceans, right? For example, and ship to ship, and also they exchanging information.
Yes. Yeah. So AIS is standard for the marine domain.
Mm-hmm.
And the surface vehicles will have an AIS beacon on them. And each domain has its own way to share the information. However, you do not have that across domains.
I see.
And you you will with the increasing number of vehicles and the increased complexity of the missions, you see more and more cases where you have missions across multiple domains. You will need to do things that involve an air vehicle and a surface vehicle, potentially an underwater vehicle.
I see.
The scenario is very simple. You will use the air vehicle to give you a situational awareness for the surface vehicle, because if you have an autonomous boat, the forward-looking camera tends to be useless because it's always covered with spray. You don't see in front of you. You usually have a UAV that flies and looks for other things. And you may also use them as relay. So you can relay information using the air vehicle to the surface vehicle, and potentially from the surface vehicle to an underwater vehicle. Or so you also have assets that are in the middle of the sea. Like you're thinking, if you're thinking about all the wind turbines and all the oil rigs, they tend to require both air and underwater surveys for maintenance and for inspections. And that is the part where you want to have at least a common operating picture.
Okay, so I have one question from the Arash. So I'm going to read his question. And thank you for your presentation. In communication, you talk about base stations. Are these base stations similar to cell phone, or they use a satellite to connect unmanned vehicle to control room?
You can have both LTE-based. You can have LTE-based stations. You can have satellite-based communication, and you can have normal radios. So all of them are possible.
I see. Okay, so while I'm receiving the more questions from audience, and I'm trying to understand a little bit more other background information, like you unmanned traffic management, the UTM domain. my understanding is they, vehicle to super control stations, they actually receive all the information from all the vehicle, unmanned vehicle, and then they're showing where they are. And
Yes.
I'm basically talking mission planning stuff, right? Would it be enough for having this super centralized the positioning and navigations for understanding how I'm going to planning? Why I need to know the directly communicate other platform. So what I'm saying is
You
all the
don't,
platform can communicate
you,
with the center, and then
you don't need to communicate with other platforms, but you want to know where the other platforms are.
okay, right.
So taking control of another vehicle is something that you may want to do within your organization.
Mhm.
However, you as an operator, uh, especially if you fly something that's larger, you
Mhm.
want to know where other things are, and the other things that are flying around may not be yours,
Mhm.
may not be part of your network, they may send telemetry, they may send their position in a protocol that you're not aware of.
I see.
Like imagine that Amazon and Walmart are sharing, are putting up drone deliveries.
Mhm.
And in current situation, unless you are equipping everybody with an AIS beacon, you don't know where things are. You don't know what corridor, what altitude I'm flying, what altitude you're flying, and so on.
I see. Right. So this standardization is actually all the modular payload and command control are standardized. So therefore, um, the where they are, how to activate it, and how to motorize them are informed to the central part, right? And then we share all the informations. Am I right?
You can see it that way. You can see it as every entity is broadcasting, has a web service where it publishes and you subscribe to that information.
Mm. Mm.
And you can have like York University has its own service that publishes the position of all the unmanned vehicles that
Aha.
you have currently operating.
I see.
And if somebody needs to know, they connect to that service and they can pull that information in their ground control station and their system.
I see.
And then they see, okay, I'm flying here, but also York is flying 3 drones, and they may do some ground vehicle experiments, and I know where not to be.
Hmm. Well, that's very interesting, right? So maybe I'm not a domain expert in this particular field, but it's a very powerful claim. So as a company, Kongsberg, and what is big motivations for standardizing? Um,
What is the big motivation is it reduces cost. It reduces cost to for the end user, in both training, and then you want a system that doesn't have to change every time you bring things into it.
I see.
And especially in the command and control, in the situational awareness, you do not want every time somebody brings a vehicle into your operation to go and see if you need to update or not. You just want to keep it as stable as possible.
I see. I see.
So it's more an operational demand.
I see.
It's an operational drive.
Right. So I guess the standardization, I think a fundamental, the problem is how we make everybody follow, right? And execute and, the compliance to the standard, right? It's usually led by.
Yes, there are two aspects. One is to get people to to agree upon a standard and then get the people to use the standard.
Mm-hmm.
And sometimes first one it's easier than the other one.
Mm-hmm.
And it will be probably an effort from top down, in the sense that the authorities will have to mandate the acceptance of, or mandate certain things to be published in a standard format.
I see. Okay. So you mentioned about the project in the 4D robotics, if I correctly remember, in Scotland. So it is about the data modeling and demonstrating it cross-domain, I guess.
Yes.
So what sort of a current status of that project?
We are getting towards the end of it.
Uh-huh.
So we're closing it probably August.
I see. So what is the next step after that project?
What is the next step after that project? We will probably commercialize the project. We also as part of the work we're doing with OGC, we will open the data model for that project. And see if we can have that as a basis for an upcoming standard. Maybe not necessarily in the form that we are currently using, but in as I said, a starting point that you look at what was done and we improve and we get the intent from that project into the standard.
I see. I got a sort of extended questions on that part, and my colleague Professor Mosgang Jadidi from York, and my understanding she is working on the data modeling standardizations with the OGC. So what her question is, thank you for your presentation. How can we mandate an acceptance of such a standard format for everyone? And how academia can help? And should we train our students? Right. So I think the very first question, how mandated the acceptance of such a standard format for everyone?
That's a great question. Well, you can use the standard. Mm-hmm. So you will say, well, in your make your vehicles speak that standard. Offer a bridge that's from the standard to your vehicle and translates the standardized commands into the whatever proprietary protocol you have. Participate in ConJoin at OGC. If you have a vehicle, well, we would love to integrate. Yeah, and so on. It's basically using it. That's how you. Right. There's no mandate. You can't mandate. You just start using it and improve it. And we're trying to make an open standard. So if you participate, that's how you make people aware of it and get acceptance.
So regarding the OGC, and I believe the ISO is also the body who, the internationally standardized things. And why OGC then? OGC and then go to the ISO, or it's not necessary, it's parallel?
OGC collaborates closely with ISO. So there are OGC standards that became ISO standards.
So it's a procedural things and OGC.
Yes.
Concept go to.
Yes, there are procedural things. Right now we are closely working with OGC, just because we found people who are facing the same problems as we are trying to solve.
So what is a particular technical committee who deal with this under OGC?
We have At OGC, we have an unmanned systems working group, and we have an aviation working group.
I see. Okay, that's very good. So, what is the your course like? It's very great. Exciting. I think I'm totally convinced the motivation of this direction. And based on what you've done is what you want to do over the next 5 years.
We want to bring, at least internally, we want to have a mature product that we can easily bring in vehicles, and we can give the product to a customer and be very confident that if that customer chooses to bring new vehicles in, it's going to be a painless process.
I see.
We also want to work with the standardization committees to bring this to hopefully a standard, or we will see after the experiments that we run with in collaboration with OGC and other partners, if this is something that is a good idea, or what can we learn from those experiments. What can maybe we learn that what we have out there is enough. Maybe we learn that we need a lot more work, and
I see.
so on.
So I have another questions, and I get to read times up, and I think that would be the last one. But Arash, the person who made the questions first time, and how authority control this unmanned vehicle? Is there an information to be shared at beginning and end of this vehicle journeys?
Right now, the authorities do not control the vehicles. Depending where you are and what vehicle you plan to operate, you may submit a flight plan or an operation plan to the authorities. That may be the air traffic controller, well, the FAA, the equivalent of FAA in your country, the harbor master, depending where you want to operate. And they need that information because there are civilian military vehicles traveling as well, and you cannot fly or you cannot move your vehicles willy-nilly. You have to know where other things are. And you may be denied to fly, or you may be denied, and you have to do other things. Like there are, for instance, if you want to do an unmanned vehicle operation in certain areas, they will put special buoys and flags indicating there are men in the water, that they're divers, so that people with jet skis or recreational boats don't travel through there. And
I see. Right.
so, but at no point the authorities have the ability to take control over your vehicle, as far as I know.
But today's, I think is all offline, isn't it? Mission planning loaded it to that FAA or whatever.
There are services in US and some European countries where you can do the planning online using the tools that the authorities provide you, and you will get the approval. And the advantage there is you have the latest information about any restrictions or any airspaces that are around you, or any restrictions that are in effect. So you can do that. And the planning, the approval tends to be automatic.
It's very interesting. Okay, I think unless we don't have any questions further, and then I think that this is limited to time, Theodore. I think so. We perhaps to finish our session, Theodore. And,
okay.
It's a really we're very pleased to have you for the last webinar series for your talks. and we learn a lot about unmanned control systems and open standard things. So very exciting path. So
Great. It was a pleasure speaking with you, and thank you very much for the opportunity.
Right. Thank you.
Thank you.
Thank you, everybody. So for the audiences, all the recorded videos will be available and from the website and YouTube channels, and those informations will be sent out to you and with a separate email. And thank you for your attendance and enjoy your summer. Okay, bye.